And Megan, thank you so much for the introduction. I also just want to do a couple of things before I get right into it. So first off, to thank Karen, Alison and Stuart for both the opportunity and for all their work in helping shape what we're talking about today. And equally, I'm coming to you all from Ngunnawal and Ngambri people's lands here in the ACT. And I'm presenting as a white male wearing a blue jumper, black glasses, a beard that I'd like to say is brown, but is actually a fair bit grayer than I'd like to admit. And my pronouns are he and him. So as Megan pointed out, I am a pretty excitable sort of character, and I am very excited to get the chance to connect with all of you today, to be part of this community, and to really talk about where and how I think this community and the incredible work that you do can change Australia and can help change the world. And if I do nothing else today, I want to leave you with the message of just how urgent it is that we do that. So the point that we're trying to make on this slide is that we don't have time to come up to these problems, these societal challenges, these environmental challenges that we are facing globally are here today. They need our best efforts, and frankly, we need to go faster in trying to bring our science, technology, and in particular, Earth observation to bear to solve these problems. We have a critical role to play, and I want to talk a little bit about what that is. But I also want to make the point, I guess, that in the same way that we have an almost ethical duty to try and solve these challenges, they're also a really key business opportunity. These are not two disparate statements. They're not in competition with each other. Actually building a more sustainable world is equally a large-scale economic opportunity for everybody. And I think that's a really important point. It's certainly, for me, a reflection, having made the move from Geoscience Australia across to Microsoft, enabling companies, enabling entrepreneurs, enabling new ideas in business to actually be profitable, to be sustainable, but to drive the change that the world needs to see. That's something that I think is very important going forward. And I think it's one of the ways we can accelerate change globally. So I want to kind of work through a couple of dimensions to this. And really, we have a clear and present issue. We have a climate crisis, we have dying biodiversity, we have massive environmental challenges to solve. We need to go faster. And one of the fundamental things we need to have at our disposal if we're going to go faster are partnerships. And different sorts of partnerships than perhaps the ones we're used to thinking of in the future. And I will just pause and apologise for a moment in that at some point I'm going to try and play a video through this talk, and inevitably it's going to fail. So when it does, we'll deal with that and bubble through, but just be forewarned. So we need strong partnerships. We need to come together if we're going to solve the sort of problems that we are facing in Australia and globally. And I want to start with one of my favourite ones, and credit to the folk from Geoscience Australia, to Claire Krause and Leo Limburner and the team there. But the partnership that came out of Digital Earth Water Bodies is one of the ones, and how it is changing water compliance work in Australia is a really critical example to me of how we can bring things together. So the figure I've got in front of all of you here is taken from the Digital Earth Australia Water Bodies product. It shows the time history of how full that particular dam is. One of my favourite dams, a water body R4XSR7 FT3. GA, we have still got to get better at naming these things. But we see a time history of how full that dam is. We get a bit of a feel of when it was filled. But what's critically important is actually this data is being used by the Natural Resource Access Regulator in New South Wales. And I want to actually show a video from the NRA next. And I'll make the point as you watch this, the key here is actually NRA's ability to monitor and test and stop water theft across the Murray-Darling Basin, or the pieces that they're focusing on, is being driven not just by DEA water bodies, but by all of the technology and satellite data that they're actually able to access and use. Oh, this doesn't bode very well. And we will skip directly over the video. I'll put the link to that into the chat when we're finished. But so let me try to paraphrase what is said far more articulately within the video itself. Our colleagues from NRA have actually used a partnership with the Murray-Darling Basin Authority and Geoscience Australia to build their own satellite intelligence system. Now, that system is being driven by Landsat data, by Sentinel data, much of which is coming through Digital Earth Australia, as well as data from Planet. And it's actually that partnership between a key government agency with a job to do on the ground in the form of NRAR, with major policy and technology agencies like Geoscience Australia and the Murray-Darling Basin Authority, and commercial satellite providers. And it's actually bringing all three of those groups together, all three of those data streams, the Sentinels, the Landsats, and the Planet data, that is actually allowing to see the sort of step change on the ground in water compliance that NRAR has been able to do. And I'll just make that point because quite often I think we look at each of these different data streams independently, the public good data, the commercial data. Actually, real value is going to come when we work out how to bring those together, when we actually set up systems that allow us to get the best out of both of those data streams, the public good and the private. That's where we can actually see change on the ground that will be transformative in our ability to manage, in this particular case, water. One of the other ways, though, that we can accelerate this, and one of the things that Microsoft is doing in terms of partnerships, is trying to partner with companies, with startups in this particular case, who we think we can help actually take their ideas to market faster and accelerate the pace with which they are working. And I'll make the point, a common theme throughout this presentation, and I hope throughout the mini forum itself, is that we have this need to find ways we can help each other go faster. So in this particular case, Microsoft has established a program that is really looking at small startup companies, so comparatively young companies, and seeing how we can actually bring our technology and equally our expertise at taking digital products to market to help them accelerate. And I want to give an example now, and thank you to Thomas Gooch and the team at the Office of Planetary Observations for the next couple of slides, but an example of one of our first cadre of companies that are coming through that program. So Oppo is doing a piece of work in Strathbogie Shire. So out in rural Australia, what they're actually doing is helping that town, in its town planning process, get a better feel of vegetation cover. Now, the technology they're using here is taking satellite data, they're getting a sense of the greenness within each of these different shires, and they're seeing how that's changing over time. But I think one of the things that's really valuable from the work that Oppo is doing is actually in how they communicate that work back down to their customers. Now, in this case, their customers aren't Earth observation scientists. They're not geospatial experts, but they actually are town planners and people who are interested in prioritizing how they maintain the greenness of their city. And so it's important, what they actually are doing is feeding input directly into the kind of town planning and infrastructure review projects that this particular shire is actually making decisions of. And I'll make that a point when we talk about partnerships, when we talk about how we work together, that ability to actually target our science and communicate it in a way that is actually affecting change on the ground is going to be critical to us having the sort of impact that we need to have across Australia and across the globe. And if you look at the partnership angle of this between Microsoft and the companies that are coming through, you can see text on the left here, quotes from both Spiral Blue and Oppo in terms of how Microsoft is contributing to their success. And I'll note that one of the learning labs later today is actually from colleagues at Spiral Blue, helping think about this. How do you better have empathy for your customers? How do you co-design solutions that will make sure they are affecting change and actually influencing customers to have an impact? And I think that's another part of all of these partnerships, is where we look for different groups with different skills that can come together, that can amplify each other's work, and that can really accelerate the sort of impacts that we want to have across the region. Another partnership I want to draw out is the investment within open source. And I point to GDAL here and just highlight all of the people that are starting to invest in GDAL. Now, many of you will know GDAL, and I would imagine all of you in one form or another in the geospatial tools that you are using GDAL to really drive that forward. But the way open source communities and open source efforts like this actually work is through support. It's through communities that come together to really lift, invest in, and drive forward open source communities. And I'm really proud that Microsoft, along with a whole bunch of other partners that you can see on screen there, are actively investing and supporting the drive of GDAL. And I put this example as another sort of the kind of partnerships that we need to see if we're actually going to drive change. We need groups to recognize where they can invest and how important it is to invest together in these big open source exercises. And I'll talk about that again a little bit later in the presentation. But we need to do more than just have partnerships. In addition to that, one of the big things we need to do if we're really going to affect change is build trust. We need to build trust in each other, but we also need to build trust from people in how they use our expertise, in how they engage with us and how they make decisions off the back of it. And funny enough, I put this slide in after our little breakout session, speaking to some of our groups who are asking questions about how do we trust machine learning models? How do we better trust, deep learning and new approaches to analytics? And one of the things to my mind that is at the very heart of that is actually having well-structured, open networks of well-labeled data of which machine learning and data science models can be trained. And so I point to Radiant Earth Foundation. I point to this not just to highlight all of the partners that are engaging with Radiant Earth, but really to recognise that globally, groups like Radiant Earth are taking a big step forward in trying to unlock open machine learning models and critically open training data that actually will allow people to innovate, to come up with new ideas and to drive new science forward. And I think within the Australian context, one of the things that's really exciting to me is some of the work that's been happening to look at how Australia can go further and faster than these sort of global initiatives can by themselves. And here I'm really talking to some of the work that's been done by a huge range of partners, most of whom I suspect are represented here in the forum today. But this drive for Australia to establish for itself the Australian Centre for Earth Observation Quality Assurance, to have within that a robust operational set of infrastructure that is collecting data for calibration, data for validation, complementing that with a small SAT program of the cross-calibration radiometers that are actually allowing us to get better translation and better calibration of different optical satellites. This investment in Australia that position Australia to have a robust set of data, a robust understanding of what we see on the land, what we see in our environment, and how that can be connected back up to the satellite Earth observation data that we rely on so heavily. I think this is a really important step for Australia. I think it will help us attract additional investment into our Earth observation community as well. And critically, by this work also partnering with global satellite partners, by this effort actually partnering across all of the existing infrastructure and partners in Australia, there's an opportunity to really fill a massive information gap in Australia and show the way forward to the world on how we really use Earth observation data to understand our land, our water, and all of our key environmental assets. This video is going to work. I might just watch this as another dimension for trust and for using EO for making change on the land. I'll be quiet for a second when we watch this. You can listen to someone far more interesting.
Hey, Trevor, we can't hear it. When you shared your screen, did you tick the box to share audio as well?
I hope so, but let me pause and find out.
Yeah, maybe not. Maybe it's always an easy one to miss.
All right, give me 1 second. I'm assuming I can fix that now.
Yeah, just unshare and then reshare.
All right, bear with me a second, folks.
And just when you share, look all the way down the bottom left, there's a little tick box. I always forget it as well.
There we go, share sound. I did apologise preemptively for where we would get to. Let's give this another go. How's that, Karen?
In business.
Indigenous people face many challenges in managing their lands, including rapidly growing threats causing species extinctions and ecosystem losses. In response, many Indigenous groups are looking for ethical ways to design and apply innovative technologies to solve complex environmental management problems. Specifically, technology that can work with Indigenous people's stewardship practices and knowledge. The Healthy Country AI project and platform empowers Indigenous land managers to rapidly survey large areas and interpret drone-collected footage to show important changes to the ecosystem following on-ground management interventions.
Key to this effort are several AI models that enable data collection and analytical efforts to be governed by traditional owners, reflect the priority areas of concern for local Indigenous communities, respond to the seasonal aspects of Indigenous people's stewardship of their estates, and support on-ground adaptive co-management efforts. In Kakadu National Park, Healthy Country AI has been used to rapidly assess the impact of reducing paragrass weed spread on the abundance of culturally important magpie geese on the Nardab floodplain. In the Cape York region of northern Queensland, Healthy Country AI has accelerated the assessment of impacts of targeted feral pig control to protect sea turtle nesting sites. Healthy Country AI is freely available on GitHub and is ready to help Indigenous land managers rapidly survey large tracts of their land with an end-to-end solution that supports an evidence-based approach to Indigenous-led adaptive management of important species and areas.
So I highlight that incredible work because it, to me, is a fabulous, fabulous example of where partnerships have been carefully crafted to build trust. And they're really focused on the outset of building trust. And it's because that trust and respect was there in that incredibly diverse partnership that you've seen, that it has been so effective in helping land management, whether it be around protecting turtles, whether it be around reducing paragrass. That partnership to me is a fabulous example of the importance of trust. One of the other points I'd make about it is the role that technology is playing in actually enabling that sort of trust. So critically, in addition to the actual AI models themselves being public domain, the way they've been constructed is such that we're able to use technology to keep key components of the data that feeds the analytic models basically restricted. So traditional owners, we can see the detail here of the kind of 3 rings of security around that data. But technology is actually allowing us to run AI models across data that actually is restricted in who can see it. So there's a central nexus of data that is only available to traditional owners, the rangers and Indigenous elders. There's then the next circle, which can be accessed by researchers and collaborating partners, and an outermost circle that's available to the public. And the reason that technology is so important there is that you're actually able to encourage people to contribute data and insight and their own form of knowledge to a modelling practice, to have that designed in a way that it will inform their own decisions, but also where their knowledge and their sensitivities is carefully managed and carefully cared for. And I think that's a really important trend, and it is something that more and more technology is allowing us to do, and it's allowing us to get much more interesting in how we deal with privacy issues, how we deal with sensitive data, and yet still allow these next generation of analytic models to move forward. So I've tried to leave a bit of a theme, albeit with the technical challenges of playing videos. What's Microsoft doing? So those are key things that I think we all need to do. What is Microsoft doing to try and help accelerate in this space? And I really want to close just by talking a bit about what we are doing in terms of building the planetary computer. So Microsoft is really focused here on helping scale everyone's sustainability efforts. How is it that we can actually take advantage of technology, of huge compute and expertise that Microsoft has to help build communities that are focused on these critical sustainability challenges globally? And I just want to highlight a couple of things about the planetary computer itself. So in essence, it's built of 4 components. So at its heart is a data archive, all of which is based around open data standards, open data, open standards, open architecture. And that is a really important theme around the planetary computer. Because we're trying to enable others, it's critically important that all of the pieces we're building are open. They're available not just for scrutiny, but if people are so inclined, they can install this capability themselves. They don't need to rely upon Microsoft to do it. So we have geospatial data, which has got a stack catalog, and it's all cloud optimized geotiffs. We're taking advantage of things like Pangeo, the Open Data Cube, to provide us with the data querying and the processing APIs that let us take that massive geospatial data and quickly extract the pieces we want in a way that we can then undertake analytics on it. We've built a compute environment which is exploiting Jupyter Hub, which allows people to then do vast scaled compute to solve problems that they want to do within that hub. But critically, on top of those three pieces that Microsoft takes responsibility for building and putting together are the applications that partners are building. So just to emphasize that point, the concept of the planetary computer is not about Microsoft solving the world's sustainability problems. To be frank, it's about us enabling you. It's about us enabling the science community, governments around the globe, and researchers to actually come together to undertake their science and to take that to scale in a fashion that is operational, in a fashion that is transparent, and in a fashion that can be trusted because of the kind of open architecture and open nature of the infrastructure itself. And it will only be as strong as the partner communities that it enables and that it empowers. And I've got some examples here of the sorts of partnerships that we've seen that are using some of our infrastructure to build new capability, whether that be, rapid alerting and, deforestation risk analysis in the Amazon, whether that be conservation planning using Marksan. There's more and more of those applications coming together. I really want to talk about, though, the Esri and Impact Observatory's work building a new 10-meter Sentinel-2 based land cover product for the globe. Now, this product was released earlier this year. So it's been, actually the hard work's been done by Impact Observatory in partnership with Esri and exploiting and taking advantage of the planetary computers as supported by Microsoft. One of the things, and I'll just go back to that point I made right at the very start around actually having training data in order to enable these sort of capabilities, separate to this particular piece of work, so predating the work with Microsoft and Esri, there was the creation of a human-labeled, I think this data set is extraordinary, 5 billion human-labeled pixels done by the National Geographic Society, off over 5 billion human-labeled pixels that are available as training data. Now, that's really a key component of how you do any of this sort of modeling, is the availability of that well-labeled training data. That training data was then used to produce a model that was applied to over 400,000 Sentinel-2 observations globally. It's produced this global 10-meter land cover product. Critically important, though, and I guess one of the things I want to highlight is the way that it has been able to be scaled. So the model itself was able to be created within just a few months. Once it was created, it was actually able to be scaled on over 1 million hours of Azure batch and run inside of a week to produce that global product. So you're hitting a point now where these sorts of global scale products can be done in weeks. They don't need months and months of compute time to run. Because of that advance in technology, the tool itself is actually going to be available now or available shortly through the ArcGIS marketplace as an on-demand model for people to run for different areas and for different time periods. So the 10-meter product is available as a global product through the planetary computer, through Esri, and it's available free and open. The algorithm itself is now available or will be shortly available, I should say, as an on-demand capability through the ArcGIS marketplace. And I make that point because if you recall right back at the very beginning of this talk, one of the things I mentioned was the importance of both going after sustainability problems that are critically important, but also doing it in such a way that it is a sustainable business, where groups are actually able to produce products, they're able to solve problems, but they're also able to sustain a business off it. And this model of being able to produce products globally that are free, but then selling some of the IP through things like the ArcGIS marketplace, I think is a really exciting way forward, where we're able to start to see this hybrid model and this integration of, frankly, doing well by doing good. And I'm conscious of time. I want to close up with the same quote that I started with, or in fact, a slightly paraphrased version of it, which is frankly, again, if we do nothing else here today, I want to put out a call to this entire community. We have to go faster. The kind of sustainability challenges we are facing globally today are huge, they are immediate, and they need our best efforts. The only way we will do that is through partnerships like the Earth observation community that is on this call today. I leave you with a call to action. Create new partnerships, use today to create new networks, but also reach out, come up with new ideas, and take them. The world needs your very best. And I'm very grateful for the opportunity to talk to you about it today. Thank you very much.
Thank you very much, Trevor. Your knowledge and enthusiasm certainly come through. That was a fantastic presentation. You've made well, I don't think you need to convince a lot of the audience here of the urgency of the challenges that we're facing. And I think you've made a very compelling case to show that collaboration is really essential to address those challenges and in rapid time. You've given us some fantastic examples of the benefits of that kind of collaboration, different sorts of organisations, Australian, global, and so on. I'm looking at some of the questions here from our participants, and a top one that's being asked. You talked about trust a lot too, and I think you probably partly addressed this question, but quite a lot of people are asking, how can we trust major commercial platform providers? How do we avoid lock-in, and how do we sustain competition?
Yeah, so look, great question. Let me try and give a couple of thoughts on that. I'm not sure it'll be the answer for everyone, but I'd say a couple of things. So one, that sense of trust is one of the reasons from Microsoft's perspective. I can't see for other platform providers, but for Microsoft, that is one of the reasons we're investing in open source technology and why we are committed to things like open architectures. So I clearly need more coffee for this talk this morning. So that investment in open, that idea that if someone doesn't want lock-in and using our particular infrastructure, they're actually able to take much of the capability and take ownership of it themselves. Now, it's very difficult to do that for those petabyte scale data sets, obviously, but the more of the architecture that we can make open and transparent to people, we think that's a really important feature for trust. I'd also make the point that in terms of trusting groups like Microsoft, the key for us is, if you think about what our mission is as a company, it is to empower every company and every person on the planet to do better. In that sense, this is really one of those absolute critical issues. If we're to empower every person on the planet, every company on the planet to do better, then we need to be trusted. We need to be transparent. It is a fundamental principle of ours, and it's something we're really proud of. And it really drives the kind of architectural decisions we make to avoid people feeling like this is a lock-in as opposed to an open attempt to help build and engage with the community.
Thanks very much, Trevor. Talking about open architecture, I think, for my question here, talking about open architecture, I think leads to another question that quite a few people are asking. At the end of the day, who's going to pay? What business models do you think will work? And there are all sorts of options there. Decision makers pay when they consume the information, or app developers when they consume computing capability or power. How do the data providers get paid?
So I don't speak about the data providers straight out, but I would just kind of reflect. One of those points I tried to make right at the start of the talk is actually sustainability is a huge business line. It is, so a company like Microsoft has a huge number of customers that we service. We're a technology company looking to empower others. And increasingly, all of those businesses are asking us, how can technology help us achieve our own sustainability goals? And I think that comes back a little bit, Megan, to the point. If you look at the startups program that Microsoft's running, that is about helping companies who have got good ideas scale those to the market. And there is a market there for those products. And I think that in turn drives a commercial model where companies are able to innovate. They're able to develop products that help drive a more sustainable agriculture sector. They help drive better land management decisions, or whether that be for carbon farming initiatives. Those markets are there. It's actually accepting that getting to those markets will take both the skill and innovation of companies and partners who are on this call today, in some cases, it'll take the grunt of companies like Microsoft to help show them how to take those to scale. And in other cases, I think I just come back to partnerships. Partnerships between public good and private data. Partnerships between people who hold data protected but want to see it used. Those partnerships that are based on trust, respect, will start to find markets. And I've got no question that there is investment to be had.
Thanks very much, Trevor. I have another question here. I'll put it to you, but I'm sure there are lots of other people in the forum too that will be bursting with responses. A lot of Australian science, Earth observation science, is built on instruments from Europe and America. Given the value that we in Australia are deriving from these, are there movements for Australia to contribute to or develop public good Earth observation instruments?
Yeah, I could almost hazard a guess where that question might have come from, actually. So yeah, look, and again,
there are quite a few votes for it, so it wasn't.
I can imagine. Well, and to be honest, if you look at that slide I put up with the work that that Uni New South Wales, Frontier SI, and EOA have actually driven across Australia, right? There is a clear, I don't think just a need from a data security point of view. I actually think there is an opportunity for Australia to actually lead globally. I think the investment in on-ground infrastructure to really be able to calibrate and cross-calibrate different sensors is a critical piece of that. But I also think, you know, some of the work with AquaWatch, some of the work out of ANU around the FireSat, you know, that model of where Australia can take our innovation, our expertise in doing remote sensing and EO-based problem solving and grow a manufacturing sector that can actually put satellites up that can contribute to Australia, but also can contribute globally. I think that is a really, really big opportunity for Australia. I think the other thing that makes that a really big opportunity is the incredible work that's done across these global partnerships like CEOS, like GEO, where actually we have partners internationally who respect our work in Earth observation to the point that they actually see great value in partnering with Australia to build those. We don't need to do it ourselves. We can actually leverage our fabulous relationships and the work of the Australian Space Agency and many, many others in building those. Really means we've got a platform for success there that I think could be transformative for Australia, but equally the data and the insights shared back with the globe could be transformative globally as well.
No, thanks very much for your perspective on that. Yeah. I think that's probably a conversation that will be taking place amidst some of the groups and our sessions later in the day. So thanks for your thoughts on that. Taking a slightly different tack in terms of questions, there are a few here that are raising questions about the environmental cost of cloud computing. Cloud computing isn't free, including from a carbon footprint perspective. Given how computationally complex these huge EO data sets can be, are there any initiatives or metrics that look at the sustainability impact of a planetary computer? And a related question coming from some people, as heavy compute users, how do we trade off the resource requirements with the compute requirements? The impact of the computing.
So, sorry, what was the second part of that question? I caught the first part about the, you know, big scale, big compute costs and carbon footprints associated.
Sorry, I think the second question is really asking a similar thing. Our Earth observation work is very heavily computational in terms of resource use, and yet we're concerned about our environmental impact. The computing itself is using a lot of environmental resources, carbon footprint, and so on. How do we reconcile those things?
Yeah, no, look, great question. So there's two parts to that, right? So first of all, we've got to be honest and look at the benefits of what we do. And I think, so I've chosen in this talk to not try to convince the audience that I believe are already on board that EO has a role to play in changing how we manage the environment. But I think for anyone outside of this community looking in going, well, it's very expensive to use the compute, that is true, no question about it. But equally, the power and the impact we could have in being able to measure, monitor, and actually manage in almost real time every aspect of the world's environment. Frankly, if we don't do that, we will fail. As a world, as a globe, as a community, we will fail in managing the environment in the way we need to. And that sense of urgency, that sense of needing to come together and bring the best that all of us have got, I think the benefit side of the equation is there to be had, and we have got a critical role in, frankly, helping the world avoid the very climate crisis that we're concerned about. Well, on the other side of that, so I'll put a link into the chat, but Microsoft has recognized that right across the board. Okay, so we know that we have to, so of the 4 major commitments Microsoft made last year, number 1 is that we will be carbon negative by 2030, and we will actually have removed the emissions that we have put up into the atmosphere as a company since we came into existence in 75 by 2050. So that the impact that our company has and causes, and we include all 3 scopes of our emissions in that carbon negative commitment, right? We're looking at everything. We are being really transparent about it. And it's because we recognize that for the benefits of cloud computing to really, really be achieved, we equally need to invest both in reducing our emissions, in technologies that make cloud computing less emission intensive, but equally in genuine carbon removal to reduce and remove emissions from the atmosphere. And I'll make another point of that, because there's an obvious next question, right? The cynic, I'm sure there are cynics in the audience, not many, only 1 or 2, but I'm sure there's a couple who will look at that and think, well, that's great, but how can we trust you, Microsoft? So again, and I'll put the link to this into chat a little bit later, but we equally are being very deliberate and very transparent about our efforts, particularly around carbon removal. So earlier this year, we put out a white paper on our first ever carbon removal purchase. And we've tried to really expose what the market looks like. What market is available for carbon removal? What were the challenges? What sort of came to us? And we are not just continually learning to do that better, but we are continually being transparent and open about our successes and our challenges in that space.
Thanks very much for that, Trevor. You can see you're getting some reaction from the audience there who are appreciating the points that you're making. Thanks. We're moving to the end of this session, so perhaps I might choose a question that's on a different tack. With the examples that you presented us, we can see fantastic data, fantastic models, use of the data and collaborations, but we need a skilled workforce. We need skilled people in the organisations to be doing these things. So a particular question that's got a lot of interest here is, how do we enable research in government and industry to be supported and progress to more operational programs, and how do we build that suitably skilled workforce to do this kind of work?
Yeah, that is such a big question. I'm not sure I've got quite as compelling an answer. So I guess I would say, digital skilling, full stop, is a huge challenge globally, not just in Australia. It is a massive area. And Microsoft, like many others, are investing in programs to build that digital skill data set and to enable people with the not just the STEM skills, but also the digital science, the data science skills that are going to be needed. I don't really have an answer for how to, ensure research agencies and governments are funded to be operational, other than to kind of hammer on one of my themes at the start, which is partnerships, is for looking at ways that we can actually get the most efficiency out of the investments that are made in our operational infrastructure, to leverage the expertise that we have in big companies like Microsoft that can take care of some of the base operational areas, but really recognize that what we want to do is invest in the innovation on the top of that, on helping people go to market on top of that. And I think there is still huge opportunity to do more in that space, Megan, but I'm not sure I have the answer to it.